Alright, last video for section 2.5. And this is a new concept. So, last couple of videos we were just doing examples. And this one is really a little tricky. But fortunately, there's patterns to it. So, we're going to look at the second derivatives of implicit equations. Okay, now these, I'm just going to tell you right away, these can be a little bit difficult. So, you have to put the skull and crossbones. These can be treacherous. So you have to be really careful. But fortunately there's a pattern, and I'm going to show you the pattern. So let's just do this as an example. So for example, let's say I'm given the implicit equation y squared plus 2y is equal to 4x squared plus 2x. And I want to find the second derivative, d squared y dx squared, in terms of x and y. Alright, so finding the first derivative is relatively easy, but we need to do it. You'll see why. So step one is we want to find dy dx. Okay, so I'm going to take the derivative with respect to x of both sides. So I've got d dx of y squared plus d dx of 2y, so I'll bring the 2 out front, d dx of y. And that's equal to 4 d dx of x squared plus 2 times d dx of x. Alright, so let's march through this. The derivative of y squared with respect to x is 2y times the chain dy dx, plus the derivative of y with respect to x is just 1 times the chain dy dx, but there's that 2 out front, so it's plus 2 times dy dx. And then on the right hand side, same. So the derivative of x squared is 2x, so 2x times 4 is 8x, plus the derivative of x is just 1, so 1 times 2 is 2. Okay, so let's see what we can do here. First thing I'm going to do is I can divide the whole equation by a 2. So this one becomes 1, 2 goes into 8 4 times, and 2 goes into 2, 1. So I'm going to rewrite this. So I've got y times dy dx plus 1 times dy dx, that's just dy dx, is equal to 4x plus 1. Okay, so now remember, I want to isolate dy dx and get everything with dy dx on the left hand side, which it is. So all I need to really do here is factor out the dy dx here. So I've got dy dx times y plus 1 is equal to 4x plus 1. So the first derivative of this implicit equation is going to be 4x plus 1 divided by y plus 1. Now we have to save this for later. And this is part of what makes this tricky. Okay, so we're going to save this for later. So I'm going to start a new page, but I'm going to go ahead and write down the derivative, what that derivative was. So we just found the derivative of this equation, and that was dy dx. First derivative is 4x plus 1 all over y plus 1. Okay, step 2. Step 2 is we want to find the second derivative, dy squared dx squared, by taking d dx of both sides. Okay, so if we do so, I've got d dx of dy dx, and that's equal to d dx of 4x plus 1 over y plus 1. Alright, so let's do the left-hand side first. So I've got the derivative with respect to x of this dy dx. And so that's just going to become d squared y dx squared. Now on the right hand side, I've got a quotient rule. So I've got u divided by v. So u is 4x plus 1, and v is y plus 1. So u prime with respect to x is just going to be 4, and v prime, the derivative of y plus 1 with respect to x, is going to be 1 times the chain dy dx. Okay, so I'm going to put the quotient rule then over here. Okay, so my quotient rule is everything is over y squared. So that's, is everything over v squared. So that's y plus 1 quantity squared. And then on the top in the numerator, I have u prime, which is 4, times v, which is y plus 1, minus u, which is 4x plus 1, times v prime, which is dy dx. Okay, now we're not done, and this is what's confusing. Notice here we've got the dy dx term. And in the problem, it always is going to ask you to find the second derivative in terms of x and y only. So what you're going to have to do is go back up to your first derivative up here and insert that in for any dy dx's. So I'm going to go ahead and insert that. So my second derivative is going to be equal to 4 times y plus 1 minus 4x plus 1 quantity times dy dx. And dy dx is 4x plus 1 all over y plus 1. And this whole thing is over y plus 1 squared. Okay, now, listen carefully. This is really important. Okay, don't touch the denominator. Ever. Just leave it alone. But the one thing you do want to do is in this dy dx term, you have this y plus 1. And you're always going to have it. It's always going to be the same pattern. And notice how this y plus 1 here is the same as the y plus 1 down there. It's always going to be the same pattern because of the quotient rule. And it just always going to work out that way. So at this stage, what you want to do is you want to factor out a 1 over y plus 1. In the numerator. So to do that, I'm going to go over to this first term, and I'm going to multiply this first term by y plus 1 over y plus 1. And by doing so, I can factor out a 1 over y plus 1. Okay, so if I do so, then I get d squared y over dx squared is equal to, I'm factoring out a 1 over y plus 1 in the numerator, and I get 4 times y plus 1 squared minus, and then I multiply these two together. Don't distribute it. I mean, most of the time you don't want to worry about distributing it, but you can kind of see that distributing it is not going to help you in this case. So this is 4x plus 1 squared, and this is all divided by y plus 1 squared. This is always going to be the same pattern. Okay, so let's go back up and look at it because this is really confusing. So when you put the dy dx term in, this term down at the bottom is always going to match up with this. And so what you need to do is factor out a 1 over that, which is what we did over here. And when you factor it out, notice that this guy right here, this y plus 1, belongs with his buddy, his pal down here, this y plus 1. And so I'm going to put those two together, and I get 4 times y plus 1 squared minus 4x plus 1 squared all over y plus 1 cubed. Done. And that's how you find the second derivative in terms of x and y. Now, here's where you're going to run into trouble. Let's go back up here. Alright, so here's what we're going to do. So you've got this dy dx. So wherever you have a dy dx in the second derivative, put dy dx in from your first step. Okay, second thing is once you do that, the denominator of dy dx you always want to factor out. So factor this out of the numerator. And when you factor it out, then it's going to belong with its pal down here. The only thing you need to be concerned with is that you need to multiply this term by what you're factoring out. I really encourage you to go through this example on your own before you start the homework, because it can be a little tricky. All right, so this is it. So hopefully, this will get you guys started on your homework, if not completely done. And the homework for 2.5 will be due on Monday, and I'll be back to answer questions about it. And this is actually one of the more complicated sections in terms of algebra. And so, again, it's really important that you organize your thoughts well, and that you make sure that you organize yourself very well. The other thing I want to caution you on, and I've seen this before, a couple things. One is you're writing down lots of x's and y's. And so I've seen people before who write down x like this and y like this. And when you've got, literally almost a dozen x's and y's floating around, if you write your y's really fast, and there's your y, and here's an x. On tests and quizzes, when you're going line by line for simplifying these implicit differentiations, your y now looks like an x and you make a mistake. So what I strongly encourage you to do is make sure that you write your x's like this and put a little loop on your y. That will help you prevent a mistake. The other thing is, when you have dx's and dy's floating around in an equation, I don't know, so let's say you have like a sine of xy, and then you've got a dy dx, and then you've got minus 6x, and this is equal to 5, plus, like, I don't know, 8 tangent of y, dy dx, or something like this. This doesn't even make sense, but anyway, it doesn't matter. So what you need to do is just remember to isolate things that have dy's, dx's, and get all of those on the left-hand side. And anything that doesn't have a dy, dx, you can get those on the right-hand side. The last thing I want to say is, if you have something like this, where, let's say, and we did an example like kind of like this, but let's say we have like a cosine xy times y plus x dy dx is equal to like 5 plus dy dx. Okay, before you can isolate your dy dx's, in a case like this, you have to multiply out first. So the reason why is that you can't isolate the dy dx when it's wrapped up in this parenthesis. So you first have to multiply out that cosine of xy, and then, and only then, can you isolate the dy dx's. And like anything in this class or any other math class, it just takes a lot of practice to kind of get used to it. So practice the homework, work together, and do your best. And I'll help clear up anything when I get back on Monday. All right, have a great rest of the week and a great weekend, and I shall see you soon. Thank you for watching these. I hope they weren't too terribly boring. All right, take care. Bye.